What if I told you that the 3 minutes you waited to get your coffee from the cafe this morning, the time Netflix takes to show your favorite show, and the way Amazon delivers millions of packages on time all depend on the same mathematical principle? Welcome to the fascinating world of queuing theory, the invisible science that organizes our entire modern world. Before starting today's video, I am Mehdi Hassan. I make videos on operation research and supply chain related topics. If you like this video and want to gather some more knowledge on operation research, then check out my other videos as well. Now let's jump onto our today's topic. So let's start with the basics. What is queuing theory? Queuing theory is the mathematical study of waiting lines. Think of it as the science of managing flow. Whether it's a customer at Starbucks, data packets traveling through the internet, or cars on a highway, queuing theory helps us understand and optimize how things move through systems. Every queuing system has three essential components: arrivals, things entering into the systems, example customers, calls, data, service, the processing that happens like taking orders or handling equipment, and departures, things leaving from the system like satisfied customer, completed deliveries. Magic happens when we mathematically model these relationships between these three components. We can then predict wait times, optimize staffing, and even prevent systems crashes before it happens. Here is a complete queuing theory analysis using MM1 model for a simple service system. MM1 model refers to customer arrives randomly and the service time changes exponentially, meaning that the last person waiting in the queue will be waiting for the longest time. So problem setup. Consider a single server queue. As an example, one coffee shop counter. So assume arrival rate lambda equal to 10 customers per hour, and it is Poisson process happens randomly. Service rate mu equal to 12 customers per hour. Now here is the question: as arrival rate is 10 per hour and service rate is 12 per hour, so why should I think about queue? Because the customers are coming randomly, so queue might happen. So let's get back to our mathematical solution. Utilization rho equal to lambda by mu, which is 0.83, 83%, and customer in the system is 5 customers, customer in the queue 4.17 customers, time in the system half hour or 30 minutes, and time in the queue 0.42 hours or 25 minutes. So we have calculated all things. So then let's take the decisions from the analysis. Queuing theory reveals these key decisions. Here it is like 83% of utilization, which is very high utilization. Risk instability during peak time, and average customer have to wait around 25 minutes in the queue, which is poor in most of the cases, and this means a long waiting time and long congestion, less customer satisfaction. And also 4 plus customers in queue signals need for better space or a virtual queues. So from that mathematical problem, if it happens to any counter, then this is the way service could be improved. We could add another server, and which is like hire second worker during the peak times. It would cut some waiting time and speed up the service, like training the staff and use faster tools and queue segmentation like express lane for quick tasks. Now here is what really gets exciting. Let me show you how big companies use queuing theory to make billions of profit and keep you happy. Let's talk about McDonald's. They did not become the largest restaurant just by an accident. They are master in queuing theory. Like every McDonald's drive-thru designed using queuing theory. They have calculated everything. Optimal menu board placement. Customer needs at least 90 seconds to choose what they like, to add an extra staff during the peak time, and even exact angle of drive-thru curve to maintain and to maximize customer satisfaction. Result, they can now serve over 69 million customers daily across that's 800 customers per second worldwide. Now let's move on to virtual world. Ever wonder why Netflix rarely buffers even when millions are watching simultaneously? Think about queuing theory. Netflix uses advanced queuing models, predict peak viewing times like Thursday nights are brutal, pre-position content on the server closest to you, manage bandwidth allocation across the global bandwidth, and optimize video quality based on network congestion. They operate over 15,000 servers across 200 countries. Their queuing algorithm ensures your show starts in under 3 seconds. That's handling 1 billion hours of content every month. So here's the mind-blowing part. Queuing theory touches dozens of times every day in your life. When you stream a video without a lag, get through airport security efficiently, find a parking spot at the mall, or receive same-day delivery, it is all about the magic of queuing theory. So let's wrap up. If you found this video fascinating, you will find my other contents informative as well. So hit that subscribe button and ring that notification bell icon. Trust me, understanding these mathematical principles will change how you see the world around you.